Happy Monday. I hope you guys have a fantastic weekend. And here we go. We are going to continue with 3.2. So you should have out your 3.2 notes, your blue interpretation sheet, and a calculator. You're going to need to have that out every day this week. Notes, blue interpretation sheet, calculator. Okay? So I want to remind you guys from last Thursday, okay? What is a residual? So just to remind you, a residual, that is when you take the y value and you subtract the predicted y value. So the actual y value from the data point minus the predicted y value, which you get from the regression line, okay? So the actual y, this is from the data point, and y hat is from regression prediction. Okay, so that's what you are doing. You're taking the actual data values y and subtracting the predicted y value. All right, remember that if your residual is greater than 0, then that means that the data point is above the line. This is on your blue interpretation sheet. If the residual is less than 0, the data point is below the line. And if your residual equals 0, then the data point is on the line. So remember, that's what the residual means. And so let's look at an example. I know some of you guys, we did this in class on Thursday, but I want to go ahead and go through it again for those classes that did not go through it. So calculate and interpret the residual for the can that was tapped for 4 seconds and had 260 milliliters of soda remaining. So I am talking about a specific can. This particular can had an X value of 4 seconds and a Y value of 260 milliliters. So this can was part of the experiment, and if we look at the graph, we could actually find that dot. We go to 4 on the X, and we see Y is 260, and we see that dot on the graph. So to calculate the residual, I'm going to need, I'm going to need the actual y and the predicted y. I already have the actual y value. The actual y value is 260, but I need the predicted y. In order to do that, I'm going to need the equation, and I'm going to need to plug in 4 seconds for x into the equation. So from the other side of the paper here, soda hat equals 248.6 plus 2.63, and I'm going to plug in the x value of 4 and see what my predicted y value would be. So if we calculate this, we get 259.12 milliliters. That is what the line predicts the can would have if we tap it for 4 seconds, okay? So now I'm going to take that prediction and put it into my residual equation. Now I just do that subtraction, and my residual is 0.88 milliliters. Now, notice that this is a positive number. That means my data value, which is the actual dot, should be above the line of best fit, or the regression line, okay? So what does that mean in context of this problem? That means that this can of soda had 0.88 more milliliters remaining than predicted. It's positive, so that means that my actual value of 260 is higher than what was predicted to happen. So I actually had more soda remaining than was predicted. All right, let's look at a different example. So here's a problem. Researchers studying acid rain measured the acidity of precipitation in a Colorado wilderness area for 150 consecutive weeks. Acidity is measured by pH. Lower pH values show higher acidity. The researchers observed a linear pattern over time. They reported that the regression line pH hat equals 5.43 minus 0.0053 times weeks. That fit the data really well. The actual pH measurement for week 50 was 5.08. We're going to find and interpret the residual for that week, okay? So my X value is the weeks. So this is week 50. So X equals 50. The pH is the Y value. So my Y value here is 5.08. That is the actual data value. So to find a residual, I need to take the actual Y and subtract the predicted Y. And so the actual Y is 5.08. To find the predicted Y, what do? I hope you just answered out loud. You should have. So we're going to take the X value and we're going to plug it in to the equation. So pH hat equals 5.43 minus 0.0053 times 50. We should have had a pH of 5.165. Now you can see if I just look at these two numbers, okay, the actual Y value is 5.08. The predicted Y value is 5.165. You can see when you look at those two numbers that the predicted amount is higher than the actual amount. So that means that my actual data value is lower or under the line of best fit. So here's how we would interpret this. First we get the answer, of course. So we get a negative. We should not be surprised that we got a negative number because my actual data value was lower than my prediction. And so we get a negative 0.085. What that means is that the actual pH was lower than predicted by 0.085. I don't see any kind of units, so we don't have to worry about that. Now, it does say here that lower pH values show higher acidity. So this means that in week 50, it was more acidic because the pH value was lower than predicted. It was more acidic than we expected. Okay? So that is all of 3.2a, and now get ready for 3.2b. So today we're going to talk about the LSRL. We're going to define what that even is, and we're going to talk about how to do regression in our calculator. So if you don't have your calculator out, now would be a fantastic time to get it out because you're going to definitely need it today. So my question to you guys is, if I give you a scatter plot, how do you know where to put the line of best fit? Yeah, so you kind of look at the dots and you kind of estimate like where would be a pretty good place. But how do I know that that line that's on this particular scatter plot, how do I know that that line is actually the best fit? I mean, what if it's like that line? Or like, what if it's like that line? Like, how do I know where to put it exactly?
Use your calculator.
So, that's a good thought there. So, sort of, we are going to talk about how do we know. Now, there's actually several different ways to come up with a line of best fit. In statistics, we use a very specific way to do a line of best fit, and it is the LSRL line of best fit, okay? It's the LSRL regression line. So we'll talk about what that means. So here's the first thing, though, that you got to do, or you got to make sure is happening when you are finding the line of best fit. The first thing you're going to do is you're going to find the average X value and the average Y value. And that is going to become your pivot point for your line, okay? So no matter what method you use, you're definitely going to want the regression line to go through the point that indicates what the average X's and the average the Y's are. So that point is definitely going to be on your regression line. It'll be right there in the middle of your regression line. So now, at that point now, you basically are going to pivot the line up and down until you get the best fit. But how do you know where to stop the pivoting, right? So like, where is the perfect pivot? So the way we do it in stats is we utilize our residuals, okay? So on this one, we kind of put this line on here and we go, oh, that looks pretty good, right? Obviously, right here in the middle, we've got our X bar, Y bar, right? So that's definitely there. And we've pivoted this line to be where it kind of looks pretty good. And we say, okay, let's go ahead and throw the residuals on there. Remember, the residuals are from the actual Y value to the predicted Y value, which is on the line. All predicted Y values are on the line. So actual Y value minus predicted Y value, these are my residuals. You guys, I have some positive residuals. Those are the ones above the line. I have some negative residuals. Those are the ones below the line. What would you imagine I would get if I added all of these residual values above the line and all of these negative residual values below the line? What would you think I would get? I would get a number. What do you think that number might be? Won't be 1. It'll be close to 0. And if my line is in a pretty good place, it'll probably be exactly 0. But here's the problem. Even if I have a pretty good line, but it's flat like this, I'm going to have some positive residuals on this side, and I'm going to have negative residuals on this side, and I'll still end up with 0. So that's not quite good enough. So the next thing that we would do is we would want to get rid of the negatives. How do I get rid of negatives in math? I square them, okay? So I'm going to take the residual, and I'm going to literally and mathematically square it. So basically, turn this residual into a square. So here's the distance of this residual, and I make it into a square. The area inside of this square is the value of the residual squared, because that's how I find the area of a square, right? Side squared. So I have the area now of this particular box, and then the fun begins. I do that with every single residual. I square every residual, I find the area of every single one of those boxes, and I add all of them up. I continue to tip the line, making these boxes bigger and smaller until I find the smallest sum of those squares. Doesn't that sound like a fun process? You guys look excited. Yes. So to find the residual, I just find the distance from the actual Y value to the predicted Y value, which is on that line. So it's just the distance there. So I do Y minus Y hat to find the residual. Let me show you guys what this looks like in action. Say that again. I know, right? Okay, so here's another scatter plot, right? So I'm going to throw a line on here. Boom. Is that a very good best fit line? Guys, that's a terrible line, but it's going through X bar, Y bar, so that's good. Which way do I need to go with this? Up? Which side needs to go up? The right side needs to go up? Okay. So I'm going to do this. Okay, so like where would be a really good like best fit? Like, is that good or like where should I? Here? This good? No, that's terrible. Come on, Rahul. That's terrible. That's a terrible fit. All right. This is okay. All right. So I kind of got an estimate there, but here's what I'll do. I'm going to show the residuals. So there's all my residuals. Again, I just want to point out, I know that this is a terrible fit, but These would end up actually averaging, or when I add all these up, I would get 0. So just having 0 doesn't help. So what I'm going to do is I'm going to square all of those. I'm going to square, there we go. So I turn all of those residuals into squares. Again, that's terrible. That's a terrible fit. Those squares are huge, right? And the sum of all those areas is really big, and that's dumb. Okay, so I am going to try to minimize these. Obviously, some of those I'm not going to be able to get very small because those residuals are just really big anyway. So some of those I'm not going to be able to do very well. Wouldn't it be helpful if I knew what the area was of all those squares added up?
Yeah.
It sure would. Well, guess what? Right down here, there is the sum of all of the, whoops, make that go away. The sum of all of the squared residuals is right here. 247.59 is where I'm at. Let's see if I can get this any smaller. Okay, that did not work. That's going the wrong way. It's 259, so I'm going to go the other way. Okay, look at that. I'm down to 235. Oh, it started going the other way. Okay. That's pretty good. I wonder if I move the middle any, is that going to be good? Oh, no, that's not good. Oh, okay. Yeah, that was a bad idea. Okay. I wonder if I don't know. That's pretty good. 235. That's pretty good. What do you guys think? Yeah? Okay. Well, I'm going to show you the actual regression line. It's going to show up in red. Let's see how good we did. Boom! We did very well. Okay? Again, guys, I don't want you to freak out thinking, oh my gosh, I'm going to have to calculate sums of areas over and over and over again until I get the smallest number. No, that's silly. We're not doing that, okay? This is the process that your calculator is going to go through for you. Yeah, let's go. So there's good news and bad news here. What do you want? What do you want first? You want the bad news first? The bad news is that you still have to kind of understand this process. Okay? So that's why I went through and explained it. You have some pictures here. Again, the process is find X bar, Y bar, draw a line, tip it, find the residuals, create squares, and minimize the sum of the squared residuals. And we're actually going to write that down in just a second. That's the bad news. The good news, practically speaking, you're going to plug it in your calculator and it's going to give you an answer. Okay? So, what we have found is what we use in stats. It's called the least squares regression line, also known as the LSRL, least squares regression line, LSRL. Why do you guys think we call it the least squares regression line? Well, we made as small as possible, as least as possible, the sum of the squared residuals. So that is our definition that we have to know. The LSRL minimizes the sum of the squared residuals. I have minimized the sum of the squared residuals. I am struggling to write that word. Yeah, I don't know why. I was struggling with my U there. LSRL, it minimizes the sum of the squared residuals. That's the process that we use to get a really good statistical regression line. This is all you have to know about the process that it goes through, is that the least squares regression line minimizes the sum of the squared residuals. I promise you guys that this is a test question next week. The question would be, what is the LSRL? The answer, it minimizes the sum of the squared residuals. There it is. Usually this question is somewhere on the AP exam as well, where it will ask you, what is the least squares regression line? How do you find the least squares regression line? Well, you minimize the sum of the squared residuals. That's what you need to know about what it is, okay? And then we'll use our calculator to actually do it. Let's think about this for a second. Do you guys think that least squares regression line is resistant to outliers? No? I have one vote for no. Anyone agree? If I added or changed or moved one of the data values, so think about the line, right? If I move one of the data values, is that going to change anything about the graph and the line? Is this least? Oh yeah, right? So like if I start moving data points, yeah, it's going to start tipping that line all over the place. So is the least squares regression line resistant? No. Changes in data will affect the LSRL, least squares regression line, which minimizes the sum of the squared residuals. All right, do you guys have any questions about the process that your calculator is going to go through in order to give you an answer? Yes. What's your questions? Oh, how do you do it in the calculator? That's what we're about to do. Let's talk about how to do this. So you guys, we're going to use our calculator to do this. We're just going to go through and write down the steps first, and then we'll actually go through the process. So here's how you actually do this in your calculator. You go to Stat, Edit. You're going to put your explanatory variables are going to go into L1. You're going to put your response variables into L2. So that kind of looks like when we were making a scatter plot before. Stat edit, we put our explanatory into L1, we put our response into L2. Now, to actually get the regression equation, we're going to go to Stat, Calc, and it's going to be number 8. Which is going to say ln reg a plus bx. That stands for linear regression with that form of a plus bx, which is really, really good because that's the form that we use, a plus bx. All right, now your calculator is going to ask you for the X list, which is going to be L1, the Y list, which is going to be L2. Then it's going to ask this kind of strange question about frequency of your list. This would be if we had probabilities involved or something different like that. We're not ever going to change the frequency of our list when we're doing a scatter plot. So we're just going to leave this blank. But then it asks us a very, very important question. Your calculator is going to say store reg EQ, which looks a little strange. Store reg EQ. Any ideas what that might stand for?
Store the regression equation.
That's absolutely correct, Rahul. The calculator is actually asking you here, where do you want me to store your regression equation in your calculator? Like, where do you want me to put this equation? Anyway, all right? It's going to still show you the equation, but it'll actually put the equation in your calculator for you somewhere. We are going to want to put that equation into Y1. So that's what we need to get to say right there is Y1. So in order to get our calculator to put a Y1 right there, we are going to push the following buttons. Alpha, trace, and enter. When you hit alpha, trace, it pulls up a menu onto your screen that says Y1, Y2, Y3, Y4, all the way down. And you just hit enter on the Y1 because that'll be the first one it shows. Once you do that, then you hit enter a couple more times or one more time or something, and it says calculate or paste, and then it'll show you the A, which is the y-intercept, and it'll show you what the b is, which is the slope. And then you can write down your equation. Everything's already into y1 for you, so you can use it if you need it. Life is good. Cool? Okay, so let's actually use this information and do this. You guys remember last week we did an example with 12 candies from the movies? There was this list of data, 12 movie theater candies. So you have that data there again. I want you guys to put that data in your calculator. So stat edit. You're going to put your data into L1 and L2. Explanatory goes into L1, response goes into L2.
Hey, how do we reduce fiber, do you know?
Spreadsheet.
So you would use the spreadsheet.
Yes. For the Inspire, you would use a spreadsheet.
Okay.
Yes. So put that data in. Once you have your data in, you can go ahead and follow these steps. You'll hit Stat, you'll go to Calc, you'll go to number 8. If that seems kind of familiar, you did this back in algebra, by the way. Algebra 2, I believe. And you just used number 4 instead of number 8 back in algebra, because that had the format of mx plus b. We're obviously not doing that format, but there you go. L1, L2, frequency, leave that blank. And then your Y1, you'll when you get there, your cursor should be blinking next to where it says store regression equation. And at that point, when it's blinking there, is when you hit alpha, trace, and then enter. Once you get a screen that says A equals this, B equals that, that's where you should be. That's where we're at. Okie dokie. How we doing? Did we get there? Do we see the A and the B? Okay. All right, you guys, your A should be 300.04. Your B should be 2.83. Is that correct? Okay, so what? That doesn't look like an equation to me, but it is. Here's how. Are you using 4 or 8?
4.
It's 8. Calories. Calories hat equals 300.04 plus 2.83 times the sugar. So there's our equation for our line of best fit, our LSRL, least squares regression line for our candy data. Pretty cool, huh? Now we can make predictions if we need to. If I want to know how many calories candy would have that has, 59 grams of sugar, I can plug in 59 and make a prediction. If I want to know any amount of sugar that is within the domain of my data, then I could do that. All right, you guys, I want to go through a couple things on your calculator while you have your data in and all that good stuff. Does anyone remember how to look at the scatter plot? Do you guys remember how to do the scatter plot? Second y equals. Everybody go to your calculator, go to second y equals. Does this look familiar? Okay. Go to the stat plot. Turn on the stat plot. Once you have that turned on, if you want to change anything, any of your pretty colors or whatever else, you can do that. And then hit graph. If you don't see anything, what do you push? Zoom 9. Zoom 9. Now, you guys, you should not only see the scatter plot, but because you stored your regression equation, you should also see the least squares regression line. Do you see the line? Do you? So when you went to your Stat Calc 8, did you store the regression equation into Y1?
How are you supposed to do
All right, so go to Stat Calc 8. Stat Calc 8. Down at the bottom, it says store regression equation. Make sure your cursor's next to that store regression equation thing. And you'll hit alpha, trace, and enter. And now hit calculate or enter or whatever. And then hit graph. Boom! We got ourselves a line. It's awesome. All right, you guys. Next question here says, what is the correlation value for this data? That would be the R, right? R. What does R equal? Have you guys seen R anywhere? Well, look at your scatter plot for a second. Do you guys think that that's weak, moderate, strong? What do you think? You think it's moderate-ish? Strong-ish? Moderate-ish? Somewhere in there-ish? Okay. We need the R value, so give me an R value. 0.73. That would be almost strong, yeah? That'd be close, okay? 0.63. Okay? Okay? Are we feeling okay about these numbers? That's too low?
Because it's like that's an outlier.
Okay. If only there was a way we could know it for sure. How about you guys hit mode on your calculator? Hit mode. Scroll down till you see the stat wizard. He lives in your calculator. Make sure the stat wizard is on. He's almost always on. But his little friend stat diagnostics, they like to go off. So we need to turn the stat diagnostics on. So go to stat diagnostics and turn them on. Don't you dare change the language because then you'll never get it back. Okay. Stat diagnostics is on now, yes? Okay. Now you guys, here's what you're going to do. Stat, calc, number 8. You don't have to worry about the Y1 this time because it's already there. So go ahead and hit enter.
What do we do with the wizard?
Turn on the wizard and the diagnostics.
Oh my gosh.
What? There's more things? What did you guys see now?
R squared.
You see R squared, which we're going to talk about tomorrow, and you see R. There it is. And what is R equal to?
6.2.
Huh? It should be 613.
Like that. Okay. This like
What'd you do?
it's blank.
So we get 0.618. Rahul was actually pretty close. So you guys, what is the strength of our correlation?
Moderate.
It's moderate. What's the direction of our correlation? Positive. Oh my gosh, you guys, plot twist. This is positive and so is the slope. Coincidental?
No.
I think not. This is not coincidental. If your R value has a positive association, then your slope is going to be positive. Same thing goes for if they're negative. All right, so the correlation. The correlation between sugar and calories is moderate and positive. The correlation between sugar and calories is moderate and positive.
If you have a correlation that's negative and then the slope has positive or that why?
Because if you think about, if the data is trending downward, then when I put the line of best fit on there, it should also trend downward. So like, that's why they go together. Okay, last thing I want to show you guys in your calculator, everybody just hit regular old y equals. Just hit y equals. There's your equation, if you needed to see it.
That saved me.
There's your equation. Huh?
Thanks, Stat Wizard.
Thank you, Stat Wizard. We love you. Okay, you guys, let's look at these last couple of questions here. If only our calculator had the format of the interpretation sentences, right? But we need to interpret what the slope and the y-intercept are. So my slope was 2.63? 8363? What was the slope? 2.83. The y-intercept was 300.04. We need to interpret these. That means write our fancy little sentence. So here we go. For every increase of 1 gram of sugar, the predicted number of calories will, for every increase of 1 gram of sugar, the predicted number of calories will, what will it do? Will it increase or decrease? It will increase. How'd you know that? Because it's a positive slope. Will increase by 2.83. You guys, that's not so bad. 1 gram of sugar is 2.83 calories. I mean, that's nothing. I mean, they add up quickly, but still, it's fine. All right, how about for our y-intercept? When sugar grams equals 0, so that's just when x equals 0. When sugar grams equals 0, the predicted number of calories will be 300.04. How in the world is it that we have a candy that has no sugar in it, but it still has calories? Yeah, sugar isn't the only thing that creates calories, right? There's fat and protein and fiber and all that kind of stuff, okay? Now, if you have a candy that has no sugar in it, it's probably going to taste nasty, but that's okay. It's going to be full of protein and fat for you, all right? There's my interpretation for my slope and my y-intercept. Skittles! They have sugar. They have 87 grams of sugar in them. We're going to calculate and interpret the residual for Skittles. Now remember, guys, residual is the actual y value minus the predicted y value. Y minus y hat. This is what we did on Friday. Actual y minus the predicted y. Now, I know how many grams of sugar Skittles have, 87, okay? They were one of the 12 candies that were given to you in the chart. So if you look back at your data table and you find 87 grams of sugar, you'll see how many calories are in the Skittles, one serving of Skittles.
4.
Very good. So this tells me that X is 87 and Y is 450, and that's for Skittles. So I know my actual Y value for Skittles is 450. But what does my equation say a candy with 87 grams of sugar should have as the number of calories? So I'm going to plug in to my equation, calories hat equals 300.04 plus 2.83 times, I'm going to plug in the 87 here. This is going to be the y hat value, the calories hat, y hat. So this is going to be the number of grams of sugar, the number of calories that should be in a candy that has 87 grams of sugar. What'd you get?
546.25.
Whoa! You guys, look at this. Skittles only have 450 calories. They're supposed to have 546. Skittles is a health food.
No.
Yes. So my residual here, 450 minus 546.25. That's the actual y minus the predicted y.
Oh, is that you?
This is our actual y minus our predicted y. And what do we get for our residual?
Negative 90.15. Oh, or did I get that completely wrong?
96.25. So what does that mean? This means Skittles have 96.25 less grams of sugar than predicted. Eat Skittles, get healthy. That's our new slogan.
For Blade.
No, for Skittles. We're gonna write the company. We're gonna send them all this data. We're gonna say, look, you guys, Skittles is healthy. It's good.
Technically, you mean it's less healthy than the others because there's less other stuff?
Ah, then you have the voice of reason. So, if we say, well, they have, Skittles have 96.25 less grams of sugar than predicted, but what else is there? Or maybe the other stuff is messing this up, or maybe this has two, I don't know. Eat Skittles, it's fine. It'll be fine. All right, cool. Last question, you guys. Last question. A new candy is in town. This new candy has 130 calories. This is sounding good, right? About how many grams of sugar will it have?
Oh God, algebra.
God bless America, we get to do algebra. All right, you guys, calories hat equals 300.04 plus 2.83. Is it 83 or 63? I keep forgetting.
83.
Thank you. I don't know why I'm struggling with that number. There we go. All right, you guys. Yeah, 130 calories is what we're being told. And then, so this is a two-step algebra equation. If you are not sure how to complete this two-step algebra equation, well, okay. So let's do this. How do I solve for the unknown amount of sugar?
Get rid of the 300
Just mark it out and get rid of it?
and both sides.
Oh, okay. So I'm going to subtract 300.04 from both sides. Yeah, just get out of here. We don't want you here anymore.
So, for the people that, I'm not saying this is me, but for the people in this classroom that don't know how to do this, is there a way on the calculator to do this part
Mm-mm.
two?
No. No, I mean, okay, yes, but no.
What is the yes?
The yes is you could actually use your regression table that is in your calculator that I didn't show you, and you could find it, but okay. All right, cool. So negative 170.04, is that what you guys got? Equals 2.83 times the sugar equals 2.83 times sugar. And then we're going to divide by 2.83. And you guys, Miss Rainey, check this out. This is amazing. You guys, this candy that we have just found has 130 calories, and it has how many sugar grams? Negative 60.08. Ladies and gentlemen, eat this candy and you burn sugar grams.
Where is that candy?
What has happened here? Why did we mess up our math?
Sorry, that's my arm.
Yeah, that's good. Did we mess up our math?
No.
The answer is no. What happened here? You guys, look back at your data.
We didn't have enough.
Look at your data. Did we have any y value that was close to 130?
No.
100.
We took this data and we took it outside of what it should have been. What is that called when you take data and you go outside of what it should be?
Out of the box.
Extrapolation. This is extrapolation.
You would have gotten that test question right.